For topic 4, we're going to finally look at simplifying algebraic expressions. It's kind of taken us a while to get here, but here we are. So we're going to simplify algebraic expressions in this video, and then in the last video, we're going to look at formulas, which are kind of a different idea altogether. But as far as simplifying algebraic expressions goes, this is what I told you is kind of like brushing up cookie crumbs. You can have an algebraic expression that has bunches and bunches of terms, but some of them can kind of be merged together, okay? Those are called like terms, okay? So what we do is we simplify, we brush up all of the terms that are similar into a single term, okay? So it's just kind of brushing up those cookie crumbs into piles. We want piles of like terms, okay? Simplifying can also be called combining like terms. So be prepared to hear both of those. I might say combine like terms, I might say simplify. They mean exactly the same thing, and I do use them both, okay? So simplifying an expression is the process of combining like terms. Now, what are like terms? Those are those piles of cookie crumbs we want to create. So like terms are terms that have matching variable factors, okay? So like terms have matching variable factors. This means same variables, same powers. So be careful, okay? This can be, it's not frequently tricky in this class, but it could be potentially tricky. I don't know why I said freaky. It could be a little freaky, y'all. So anyway, let's say you have x squared y, and then and you have x, y squared. Technically, you have the same variables and you have the same powers, but these are not like terms, okay? So these are not like terms because the exponents are on the wrong variables. They have to have the same variables and the same exponents on the same variables for them to be considered like terms, okay? So like x and x squared, not like terms, same variable, different exponents, okay? X squared y, xy squared, not like terms, same variables, same powers, but the powers are on the wrong variables, okay? So just be really careful. You have to have matching variable parts, okay? As far as constants are concerned, constants are always considered like terms with each other, okay? So constants are like terms with each other, okay? Now, as far as the steps to combining like terms, for some students, it's really, really helpful to group your like terms together. So if you're struggling with this, completely rewrite your expression and group your like terms side by side and then continue. But essentially what we do is we want to figure out what our like terms are, and then all you have to do is add or subtract the coefficients and then just keep the variable part the same, okay? So add or subtract the coefficients of like terms and then keep the variable part the same. Okay? So let's practice. Example 4 says simplify each expression. I did give us 4 of these, okay? And the other two situations or the other really 3 situations, we only did 2 examples, but I really want to make sure you get plenty of practice with this one, so we're going to go 4 examples, okay? So part A, it says that we have 11x plus 3 minus 18x minus 7. We have 2 different sets of like terms, okay? We have x terms, and then we have constant terms, okay? So we have 2 different pairs of like terms here. So if it is helpful to you, you can rewrite your expression. Just make sure whatever sign is in front of the term stays with the term when you move it, okay? So when you write things, when you simplify algebraic expressions, you do your variable stuff first, always end with your constant. So I'm going to focus on my x terms here. So if I were to rewrite this, I would write it as 11x minus 18x plus 3 minus 7. I have now grouped my like terms, okay? 11x and 18x, they have matching variable parts, and then constants are always like terms with each other. So what I want to do now is I want to just take the coefficients on my x and I want to add or subtract those. So since I have 11x minus 18x, I want to take 11 minus 18. Well, if I have 11 of something and I subtract 18 of it, that leaves me with negative 7 of whatever, okay? So we have negative 7x. So sometimes it helps if you think of like temperature or if you think of money. If you had $11 in your account and then you wrote a check for $18, you're now negative $7 in your account. Or you could say the temperature was 11 degrees. It dropped 18 degrees. It is now negative 7 degrees. Okay. And then let's look at 3 minus 7. Positive 3 minus 7, we're in that same situation. If you have 3 of something, you subtract 7, you have negative 4 left. So if we were to simplify this expression, we get negative 7x minus 4. You know you're simplified when you have at most one term of each type of term, okay? So that's it. We took the x terms and we brushed them into a single pile. We took our constant terms and we brushed those into a single pile. Okay. Now for part B, notice we have some parentheses. So the first thing you want to do if you see parentheses is just kind of get rid of them. Okay. So that's what we're going to do first. We're going to distribute, then we're going to do the combining of like terms. And I do want you to notice that we have 9x and then just minus a set of parentheses that has 5x minus 8. Remember, what we need to distribute is technically a negative 1, okay? So I'm going to rewrite the entire expression while I distribute. So I'm going to start by just rewriting my 9x. I want to bring it down. And then I have negative 1 times positive 5x. So I want to take negative 1 times 5, which is minus 5, and then just keep the x. And then I'm going to take negative 1 times negative 8. That makes it positive 8. Okay, and in this case, my like terms are already side by side. Notice I have a single constant and then I have two x terms. Those x terms are like terms. So I want to take 9 and subtract 5. That gives me 4, and then just keep the x. And then keep your plus 8 and you're done. That's literally it, okay? So if it helps you to think of something tangible, you have $9, you spent $5, that leaves you with $4, okay? So we brushed together our x crumbs and then we just had a single constant crumb, so we just kind of left it alone, okay? Let's look at part C. So part C, we're going to have to distribute twice, all right? And then we can do our combining like terms. And hopefully you can kind of see why distributing is really important. Right now inside these parentheses, we have 5x minus 6. You can't do anything with it, so we kind of need to free the 5x and the minus 6 from the parentheses because maybe it could combine with something else later on in the expression, which is exactly what's going to happen here. So let's go ahead and distribute first. So the first set of parentheses, I need to distribute negative 2. So I have negative 2 times 5x. So negative 2 times positive 5 would be negative 10. And then I just want to keep the x. And then negative 2 times negative 6. When you multiply two negatives, it becomes a positive. So we get plus 12. Now, in the same step, we can go ahead and distribute negative 5 through that second set of parentheses. So I want to take negative 5 times 3x. I just multiply negative 5 and positive 3. That gives me negative 15. And then just keep the x. And then negative 5 times 2, negative 10. Okay? Now, a lot of students are really comfortable combining like terms as is. And we're going to get to a point in class where we can kind of combine like terms as is. But if it is helpful for you, regroup, okay? Rewrite your expression so your x terms are together. Those are like terms. And then your constants, you want those together, okay? So you could rewrite this as negative 10x minus 15x plus 12 minus 10. And that just gets the x's side by side and the constants side by side. This is not a required step. It is an optional step if it helps you, okay? So now combining our x terms, remember we're just trying to brush them into a single pile. We have negative 10x minus 15x. So if the temperature is negative 10 outside and it drops another 15, we would be at negative 25x. And then we have 10 minus 12, which is just positive 2. So we get negative 25x plus 2, okay? So that is distributing. Make sure you watch your signs. That's one of the biggest things I write when I grade. I'm like, watch your signs, watch your signs, watch your signs. So watch your signs, double check, triple check your signs, and then just make sure you fully distribute. Everything inside the parentheses gets multiplied by what's out front, okay? Last up, we have part D, and I have 7 times 4x squared plus 3x. And then I have plus 2 times 5x squared plus x. So let's go ahead and start distributing. Again, we're going to have to distribute twice, just like we did in part C. So 7 times 4x squared. I just want to multiply the 7 and the 4. That would give me positive 28 and then keep the x squared. Next, I'm going to multiply 7 times 3x. So I really just multiply the 7 and the 3, which gives me 21, and then I keep the x. And then for the second set of parentheses, I need to distribute a 2. So I get 2 times positive 5x, which is, or 2 times positive 5x squared, which is going to be 2 times 5 is 10, and then keep the x squared. And then 2 times x is just 2x, okay? So in this case, we have a bunch of x's, but they're not all like terms. Remember, like terms are terms that have matching variable factors, meaning same variable, same exponent. So this one is worth highlighting, okay? For this one, whoops, let's do yellow first. We have x squared terms and then we have just x terms, and they are not the same. The x squared terms can be combined. The x terms can be combined, but you cannot combine this into a single term. X's and x squareds are different. They are not like terms, okay? So we will have two terms in our final answer. And if you have the same variable with different exponents, the rule of thumb is we generally go highest exponent to lowest exponent, and then we end with constants if we have them. So we're going to start with our x squared terms, okay? If you need to, you can rewrite this as 28x squared plus 10x squared plus 21x plus 2x if it helps you to group, okay? We need to take 28x squared and combine it with 10x squared. So 28 plus 10 is 38x squared. And then 21x plus 2x is 23x. And that would be your final expression. That's simplified. We brushed together our x squared crumbs. We brushed together our x crumbs. Okay. You know you're fully simplified when you have at most one term with each of each type. So we have one term that's an x squared, and then we have one term that's an x. Okay. So that is simplifying algebraic expressions. In the last video, we're going to talk about formulas, and we're going to do an applied example. And this is taken directly from your textbook. It was easy to snip. So that's what I had to do for this. So it's from your actual textbook. So you may see this again. All right.